Hello viewer. While I was able to implement all of my user stories for the Leap Trainer, there was always room for improvement. For example, the future work of this project includes the possibility of extending the software to utilize more than one controller and to introduce a system that can support multi-framed gestures. I also want to talk a little about the shortcomings of the project, explicitly when concerning accuracy. When attempting interpretation, users will notice that several letters will share fail counts. This occurs due to the similarity of the angle magnitudes. This is a side effect that occurs due to the limitations of the LMC as well as the algorithm's approach. The LMC performs best when it has a bright, high contrast view of the user's hands. Many letters require the users to position one finger above the other, which can cause occlusion. Occlusion forces the LMC to make an approximation of how the user's fingers are positioned. Sometimes it gets it right, while other times it can be dramatically off. The letters J and Z are completely unclassifiable within a single frame because they require motion to be represented. The accuracy of M, N, and T are unreliable due to occlusion. G versus Q are occasionally confused with each other, similarly with A versus S, due to their resemblance in their representation, which causes similar angles to be generated. If the captured angle manages to fall within the acceptable boundaries of the trained angle, then the Leap Trainer will consider it a pass, even if it wasn't the user's intended gesture. That's all for the Leap Trainer. Thanks for watching.
Developing with Vuforia and Unity has been an evolutionary process. The original impression we had of Vuforia's virtual buttons did not meet our expectations. Although the feature is really useful when your only device is a head-mounted display for viewing, you have no other way for using input, it proved to be too inaccurate for our users. As this clip demonstrates, the virtual buttons sometimes trigger themselves for unknown reasons. I would like to speculate that various factors such as printed target quality, camera sensor autofocus, or even the distance from the camera to the tracker are the culprits. Furthermore, developing a quality augmented reality application requires a good use of 3D modeling software, in case model prefabs are not purchased. For this project I used Blender, and it itself proved to have a large learning curve that I was not expecting. There still remains other user stories that were not developed. Most of them are related to sorting algorithms in binary search trees and their related behaviors. The system will also need refactoring in order to use a different form of interaction. Further ideas on how interaction or different ways of creating the interaction can be found in the research paper I wrote this semester for VIP. If you would like to look into it, just contact the product owner of this project and he will be able to guide you as well.